Hello everyone, this is Vijay Vandita from Sri Venkateshwara College of Engineering. Today I'll be discussing about NoSQL. We'll see the topics regarding distribution model, single server, sharding, master-slave relationship. We'll see each one by one. First, let's see the distribution model. Depending on your distribution model, you can get a data store that will give you the ability to handle larger quantities of data, the ability to process a greater read with traffic or more availability in the face of network shadows or breakages. There are often important benefits, but they can come at a cost. Running over a cluster introduces complexity, so it's not something to do unless the benefits are compelling. Broadly, there are two parts of data distribution: replication and sharding. Replication takes the same data and copies it over multiple nodes. Sharding puts different data on different nodes. Replication and sharding are orthogonally techniques. You can use either of them. Replication comes into two forms: master slave and peer to peer. Now let's see single server. Single server, the first and the simplest distribution option, is the one we could most often recommend. No distribution at all. Run the database on a single machine that handles all reads and writes to the data store. We prefer this option because it eliminates all complexities that the other option introduces. It's easy for operations people to manage and easy for application developers to reason about. Although a lot of NoSQL databases are designed around the idea of running a cluster, it makes sense to use NoSQL with a single server distribution model if a data model of the SQL store is more suited in an application. Graph databases are the obvious category here. They work best in the single server. This is an example diagram of a single server. This is a application and this is a disk for data file. Next, let's see sharding. We have different users all to different server nodes. Each user only has to talk to one server, so gets rapid responses from that server. The load is balanced out nicely between servers. For example, if we have 10 servers, each one has to handle 10% of the load. Of course, the idea case is a pretty rare beast. In order to get close to it, we have to ensure that data that isn't accessed together is clumped together at the same node and that the clumps are arranged in the nodes to provide the best data access. The first part of the question is how you clump the data so up you can user mostly gets her data from a single server. This is where aggregate orientation comes in really handy. The whole point of aggregates is that we design them to combine data that's commonly accessed together, so aggregates lead out as an obvious distribution of model. This is a process of sharding. Next, let's see master-slave replication. This is a diagram of master-slave. This is a web server. This is a slave 1, master and slave 2. Master is connected to slave 1 and slave 2. Master-slave replication is most helpful for scaling when you have a real investive dataset. You can scale horizontally to handle more read requests by adding more slave needs and ensuring that all node requires are routed to the slave. You are still, however, limited to the ability of the master to process updates and its ability to pass these updates on. Consequently, it isn't a good schema for dataset with heavy write traffic, although offloading the read traffic will be an advantage of master slave. The slave can handle read requests. Again, this is useful if most of your data access is reads. The failure of the master does eliminate the ability of handle writes until their slave is new master is appointed. This is peer-to-peer communication. Here, replication. This is node A, this is node B, this is load balancer. Master-slave replication helps the read scalability but doesn't help the scalability of writes. It provides reliance against failure of a slave but not a master. So in a master peer-to-peer replication, there is no master and slave relationship. All are considered as a peers, and there is one node which assigns work to each, and all the peers work according to their work, but there is no master-slave relationship. Essentially, the master is a bottleneck and a single point is failure. Peer-to-peer replication attacks these problems but not having a master. All replicants have equal weight. They can all accept writes and loss of any them doesn't prevent access to the data store. A prospect here looks mightily fine. A peer-to-peer replication cluster, you can write over node failure without losing access to data. Furthermore, you can easily add nodes to improve your performance. There's much to like here, but here are complications. Next, we are going to see last topic, replication and sharding. Replication and sharding are strategies that can be combined if we both master slave replication and sharding. This means that we have multiple masters, but each data item has only a single master. Depending on your configuration, you may choose a node to be a master for some data and slave for others, or you may dedicate nodes for master or slave duties. Using peer-to-peer replication and sharding is a common strategy for column family databases. In a scenario like this, you might have tens and hundreds of nodes in a cluster with data over them. This is an application example diagram for replication and sharding. This is the application. Here, this is a name balance, this is a name balance, and this is a name balance. All are interconnected. This is server A, server B, and server C. Here the first name balance does a read to the application and a replicate to the new balance. The application and new balance is interconnected. It can shift the positions, and name balance is connected to replicate to the server and read to the application. So this is a block diagram, or you can say a diagram which describes replication and sharding. So these are the ways you can go through. I hope you have understood the entire module. We have come at the end of the session. Thanks for watching. Please do like, share and subscribe my videos. Thank you.